burn these kinds of systems. In this particular scene, you can see that this was a jack pine stand, and in the scene you're looking at is lots of lichen. It wasn't all like this. There was quite a bit of feather moss in this system as well, but there was ground lichen, so it's a poorer site, poorer jack pine site. Pretty low density, which is typical of these sandy jack pine systems. So we wanted to examine a couple of features. Jin Wang looked at mortality. She cut down a bunch of the residual snags and looked at cone opening in relation to charring along the stem. Charring would be an estimation of, or a way of assessing how much canopy burning there was going on in that particular tree she was looking at. So she wanted to look at cone opening on that system. But first of all, I'm going to show you some data on the soil moisture, the duff moisture content. So it's not surprising. It's very similar to what Chuck showed this morning. You're going to have greater soil moisture in the dead stands, where you had lower moisture in the living stands. So it's not surprising, because it's predicted that we would get that. But that's more or less what we got. So in terms of Jin's result, the cone opening, cone opening in relation to char height, and char height is in meters here, and we've got living and dead trees that we brought down and tried to take apart in terms of looking at that cone opening. And so in the living trees, you generally had 2 meters of charring, 2 meters of flame height up the tree. Didn't produce that many open cones. When you have the canopy height was, the base of the canopy was about 5 meters. So very few opening of cones when you only have a ground fire that burns the lower part of the stem. But you had quite a few. You almost had 2 data sets when it came to cone opening on the dead trees, and we're trying to understand this in terms of the fire behavior. Gave us a lot of problems in terms of understanding the fire behavior. But some of the dead stands opened up immediately. You just put a light fire underneath them. They opened up. Almost everything on the canopy opened up. And then there were others that acted more like the living trees. Some of these black dots are in here, and so you have almost a split. But overall, on average, you have this kind of issue. Dead or living stands vary. These are the fire surface fires and crown fires, and active crown, meaning that it got way up in the canopy. The flames are way up in the canopy. In the living trees, you needed more fire to open the cones. On the dead trees, they started to open up quite quickly. So that's a result that I think is interesting, and it makes things confusing. And I'll show you in a minute why we're a bit confused about these results with some of the regeneration results that we got. On the same side of the coin, Maria Sharp did some work with lodgepole pine south of Grand Prairie, and she wanted to look at cone opening and on these dead trees to see whether or not the cones are actually picking up a lot more moisture on the dead trees. And we did see, as she's still working on her thesis, but some conclusions that seem to be developing. Dead trees had higher cone moisture content after a rainy period, so they pick up more moisture during when there's external moisture. They will pick it up. And cones with higher moisture content on dead trees opened earlier than cones from living trees. So anytime when they were picking up moisture, they would open up. If you put them in an oven, they would open easier. So we're convinced that there is more resin breakdown on the dead trees. So we worked through that problem. It seems to be verifying some of the hypotheses we generated earlier. So Maria Sharp then looked at this same Archer Lake stand, this jack pine stand, and you can see the girdling lines on these trees that were put in. So they were heavily girdled and killed most of the trees. And we had three different kinds of fire. We had a surface fire like this, just a light surface fire, and we had intermittent, where there's some crowning and some partial crowning of the trees. And then we had continuous fire, continuous crown fires. And we broke the sampling up into which kinds of burns we had. So if we had this kind of system, now Maria's work would suggest that we would have consumed and burned more cones in this system. We had opened up everything, but much of the seed probably would be damaged, based upon Bill DeGroot's work, some of the work that he did, that this would likely be very damaging to cones. But yet when we did surveys of the regeneration on these systems, and we found that actually the continuous fire actually did pretty darn well when you had girdled trees. These are the girdled ones that are the gray. We actually have the best results here, where I would have expected that most of the cones, much of the seed would have been lost. But yet we have the best regeneration in the stands with higher burn intensity. Well, in the living stand, we actually had the best in the surface burns. So this really produces some counterintuitive results. The good news is burning dead mountain pine beetle stands seems to work. Exactly why it works, we're not really sure, but burning dead jack pine, mountain pine beetle, or dead stands is likely will produce reasonably good regeneration. Now it's interesting, you should look at the control here where you didn't do any burning. These are six-year-old girdled stands here. In that case, this line is the girdled stand 6 years old after the killing. And that's our regeneration in terms of new seedlings. So it's not hopeful in the short run that we're going to get good results in this system. And particularly if the cones are breaking down and losing viability over the long run. So I don't know what will happen based upon the results here. Now here's some other data that we collected on these same systems. We did the duff depth. We estimated the duff depth in the living and the dead and the burned area. These are burned stands, and we looked at the duff depth in what was a living stand at the time of the burning and a dead stand at the time of the burning. And kind of what you hypothesize that you'd actually have less consumption of duff when there's higher moisture content in the burned girdled stand. And we did have that. But yet we still have greater success of seedlings in those places. So what's going on? And probably you could hypothesize, make some hypotheses as to what's going on about whether or not we've got a superior seedbed because you've got more smoldering combustion, more charcoal being produced in that system. Because you do have a fine layer of litter on the surface in these dead stands that's sitting there ready to burn, heating up that wet soil, wet duff below it. And that would produce a combustion that might be different than in the living stands. So we ended up with better results and where we have this what presumably is not a good seedbed, is not as good a seedbed, it's a thicker duff, but yet it's probably a different kind of duff. And I would think that you'd see more of this kind of charcoal-y kind of production of seedbed when you have a burnt wet soil like that. So it's wetter, but it burns with a lot more surface fuels over top of the duff. So fire-promoted seedlings, that's good. And fire in the red phase tends to consume less duff, but the thicker duff appears to support seedlings. And ground fires in the girdle stands tended to open more cones than fires in the living stands, which, and the red phase duff moisture content was higher. So we're going to get a lot of seed raining down for a decade or more after lodgepole pine, these serotinous pine stands. If we kill all the seed, kill all the trees, we're going to get it coming down for about a decade or more. And it's forest floor disturbance is needed, and so that's one of the problems here. So the fire. The good news is that fire is probably pretty effective at promoting regeneration in these stands. But fire is unlikely to be applied. So this is, I've done many research projects in my career, and this has been a very, very frustrating experience for me to take on this project, because we were supposed to do the burns in the lodgepole pine systems. And we had multiple times when things were right to burn, but we would not get permission to burn it during those times. Or the crews just left because they were already fighting a wildfire. So the combination of being too dry and losing all the crews, or the next year it just rained all year, and you never had a burn window the whole year. And we had 3 years with different scenarios of woe and grief and hair pulling. But the Goldilocks effect is a big one with prescribed burns. I think we got all kinds of opportunities to use prescribed burns to rehabilitate the stands, as Dave would point out, that need to be rehabilitated. But the reality is, probably won't do it on most years. I would say we'll probably only do it 1 out of 3 or 1 out of 4 years, and we'll spend a lot of time gearing up for stuff that'll never happen. So that's kind of the sad truth about this. So what's going to happen if we do nothing? And I think Dave answered many of the questions that we could say with doing nothing this morning. And Chris Hawkins also, Dave and Kevin Astris with some of the work that they did earlier, and Hawkins' paper from British Columbia, which suggests that we're going to get forests coming back, but their forests in British Columbia are more mixed. There are more conifers in the system. In many cases, we don't know the serotiny levels of the forest in those systems, and if they're deeply serotinous, they're highly serotinous, I'm worried that at year 10 or 15, that window that Dave was talking about, it may not happen because we may not have the seed supply hanging up in the trees anymore. And the living trees that are still in the system may not drop seed anymore at that stage, because they are serotinous coned, and they'll be holding it for the next fire. So we may not get this big a blast of regeneration that Dave saw at year 15 in the Flathead. So that's the hypothesis that I've got. I'm going to live with that because it will keep us busy in Alberta doing some more research to see whether or not it's true or not. But I would say that we won't get it, and we won't get the same level of recruitment of. We don't have as much advanced growth in Alberta, I think, as in British Columbia, because we don't have as many shade-tolerant, desirable shade-tolerant conifers like there are in British Columbia as well, in many of the forests. Although we do have balsam fir and subalpine fir and black spruce. I'll show you pictures of that in a minute. So we have many stands that are like this. This is south of Grand Prairie. north of Grand Prairie, sorry, against the Peace River. Very similar to where Derek Sitters and Tim Keddy are putting in their projects, and it's on Canfor's FMA. And we will be looking at those kinds of systems, and many of them are in the lower foothills. They tend to be in stands that look like this, with a lot of deciduous component in the stands. By the way, if we do get more deciduous regeneration, this will take out the feather moss. So if we get regeneration of aspen and other deciduous species, the feather mosses will drop out of that system because the fact that the leaf litter kills feather moss, and it doesn't take a lot of leaf litter to kill feather mosses. As soon as you drop a few aspen leaves on top of feather moss layer, you've damaged it severely. Both from light as well as phenolics that are toxic to the feather moss. So we expect to see more feather moss drop out of that system if we get hardwoods in the forest. So that might be a reason why we expect to see regeneration again with a delay. Be another reason to see once the feather mosses go, then you can get seedlings coming in underneath hardwoods. So we've got a Beyond Beetle project, and we're setting this up right now with Elle McDonald and Mike Flanagan, Nadir Urbajan, and myself. We're looking at assessing we're working with Derek Sitters and Canfor, assessing thinning and mechanical site preparation and planting and natural regeneration after some sort of a treatment. And so we will have graduate students assessing this about year 4 and 5. So after this work is well on its way, we're trying to look at the recovery of the residual trees as well, and in terms of their recovery as well as the diseases that might be associated with these systems. And we're going to be assessing fuel loading and fire risk. That's Mike Flanagan's task. He's going to look at that. You can have these richer sites, and you almost need mechanical site preparation in these, actually, to do a little bit of site degradation in a very localized area, so that it's not filled up with grass and fireweed and other things that will keep the pine out. So we will be looking at some of these kinds of things, and in this particular one, we could ask the question whether we would need to do anything, because there is enough advanced growth of white spruce in this particular stand. But site preparation will be needed in some cases if you expect regeneration to occur immediately, if you expect pine regeneration. But some of the pine is going to stay alive. As Dave said, we do see some living pine in almost every one of these stands. This one's only got a few pines. There's one behind here. There's one over there. Those remain alive. They will provide a long-term seed supply, so we're not losing lodgepole pine from that system, even if we did nothing. Some of them have quite a bit of lodgepole pine alive. We're going to be assessing regeneration in these kinds of systems in the next few years. Elle McDonald and working with some of the forestry companies are going to be assessing the regeneration in these systems a decade or so after they've been killed and not logged. So that's how we're going to be doing this. We're going to be looking at the specific ecosites and how they recover. And so Marty O'Byrne's wraparound poster, we hope to fill in some of the cells in that poster with real data in terms of what we think is going to actually happen. And we will have looking at particular kinds of ecosites, how they will recover, what kind of stand structure they had at the time of the beetle attack, and how they will recover. These kinds of stands we don't need to do anything with. that kind of stand. It depends on the forestry company. Some forestry companies have got almost a pathological aversion to black spruce, but the black spruce may be the outcome for these kinds of stands if the pine is killed, because we do have the black spruce stalking in the understory, and we do have some ridge sites that are almost certainly going to veer away from lodgepole pine if we get aspen regeneration or a thick field of shrubs developing. And in this particular example here, this is what I would hypothesize. We will get very little pine in this stand without some sort of treatment. It will go to something, but it will not be lodgepole pine. It probably will be some hardwoods and shrub combination. So with a medium site like this, we don't know where it will go. And it's not a rich site. It doesn't have a huge amount of shrub, but it will have some competition. And on the poor sites, these have got thicker feather moss, and in this case, ledum shrub layer. Once these trees start to fall over, we'll have seed beds on the rotten logs, but there may not be any seed left. Particularly if they're fully serotinous, they won't drop a lot of seed. They'll drop a little bit, just a tiny bit of seed from pine. So we don't know. So that's why we're doing Beyond Beetle. We don't know. So that's where it'll take us.